Welcome back to Mainstream PC, everyone. My name is Julian, and today I will not be appearing on screen, but instead I'll just be talking to you about this new utility called CTR, Clocktuner for Ryzen, that was written by one Asmus, also known as Yuri. He's pretty famous or infamous, whichever way you want to see it, in the Ryzen scene. He is the guy who initially wrote the custom power plan for the Ryzen 3000 chips when they were initially released, and a lot of them couldn't hit their advertised boost clocks, and a lot of people managed to get much closer or even hit the boost clocks that were advertised with his power plan rather than with AMD's power plan. So he's been tinkering with Ryzen 3000 or even 2000 chips for a while. But now he's released a overclocking utility, essentially, which helps undervolt the CPU to a manageable level where it can still maintain good all-core boost clocks and without actually consuming too much heat and pumping too much voltage into the cores. So today we're going to have a look how much that affects Cinebench and games. I'm only going to run one game though. I haven't really used the utility. I think I let it pass once, but I didn't apply the profile. So first of all, you should definitely read the system requirements and this whole guide essentially that he made, because there are some things that you will have to have before this utility can run properly. Mainly, you'll have to set some BIOS settings. I'm on an ASUS board, so I set load line calibration to 3 and phase mode to standard and current capability mode to 100%. Other than that, I have all of this, so that should be fine. I do have SVM enabled though, because I use this as a I have a VM running on this workstation. But he said it's optional to disable this. So yeah, I hope we're not gonna run into problems with that. So let's see how far we get with this thing. I've of course already downloaded it. I said I already let it pass once, but let's see how the results actually are, because I haven't tested those. So first there's a disclaimer, blah blah blah, running CPUs out of spec, yeah, at your own risk. Again, you do all of this at your own risk. If something fails, especially since this thing is still in beta, he's not taking any responsibility, I'm not taking any responsibility. We're just gonna have a quick look at it. And the homepage brings you to his Twitter homepage. Main page is this, and we should probably switch over here so we can have some detailed information about what these settings are. So first of all, these are the CCXs. So I've got a 3950X 16-core processor, which has two CCDs. Each CCD has one CCX in it. Sorry, two CCXs in it. And yeah, so this is my first CCD, this is my second CCD. And now we see what the individual core frequencies are. So 16 cores here, and temperatures for each CCX. All of this is, by the way, being pulled directly from Ryzen, AMD Ryzen Master. So you need to have that installed as well in the current version for this utility to properly work. And then there's these numbers next to each core. These are the preferred cores, or I think it's called core performance index or some jazz. I think, oops, that's not what I wanted. I think here it says somewhere CPPC or something. It's called CPPC tags, yeah. Which are basically just an indicator for core quality, as he points out here. So these are my two preferred cores. Even when I look in Ryzen Master, it says these are the ones that should overclock the best. Then I have two that are pretty high. Then there are some decent ones on my second CCX, and my other CCD's junk. Well, not so much this one, but this one is pretty terrible. Like the 136 is awful. But That's the nice thing. You can do per CCX overclocking, so you can say this thing should run at 4.3 gigahertz, this should run at 4.25, this should run at I don't know, 4.1, and this should run at 4 gigahertz, so it doesn't freaking crash all the time. So essentially, that's it here. Then we have cycle time, which basically just indicates how long the tests will run to determine like stability, I believe. Then you have the CCX Delta. I think he explains it for Ryzen 5 and 7 chips, which I believe both only have one CCD. Um, the gap or the delta between each CCX can just be minimal, or should be minimal, because as you see, a CCX is usually relatively close to each other, 64 to 44, 93 to 77. So generally they should run in similar, like generally you should be doing CCD overclocking, so an entire CCD, but you can do per CCX overclocking, but the deltas will probably not be huge. So in order to yeah, some processors obviously do this better. He even says, yeah, you can set it to whatever you want, but these are recommended values based on his experiences so far, I guess. And yeah, my 3950X should be somewhere in this range for delta between lowest and highest clocks. So yeah, yeah, if you have an XT, then it's more narrow apparently, I guess because they already run it or have better bin silicon. Um, and then Threadripper CPUs even tighter apparently. So let's go ahead and yeah, keep that at 150. My polling, I think polling was set to 500 milliseconds earlier. Let me put that back to 500 milliseconds then. And this was also active actually. So first things first, so everything is running at stock. I don't have PBO enabled or anything. So we're just gonna hit this diagnostic button. And what it's gonna do is, I think it's gonna drop core voltage and see if there's any instability, and it's gonna check V-droop on the V-core. Like if it's the load line calibration essentially is causes too high V-droop. So that would yeah, be an instability factor. So basically the diagnostic thing is just I think give us the CPU efficiency numbers already, if I'm not mistaken, and basically give us some frequencies to go off before we overclock, or before it does the automatic overclocking. So I might speed up this part because it's gonna run a few times until it reaches a minimum voltage where it feels that this is stable. Okay, so we're back, and apparently at 1.152 volts, a thread failed. Thread number 33, so that must have been somewhere in here, in this core, I believe, 33, or in this one. So apparently it wasn't stable at that low voltage. You could see it's going down by 6 millivolts every time, and then it was pegged at 4.05 gigahertz, and basically as soon as one of the threads fails or creates an error, um, the utility deems that the voltage above that is the lowest one. Now, obviously, I could go ahead and like try. Okay, maybe we could take smaller steps or something like that. But at the moment, I don't think there's an option for that. I think it's just by default going 6 millivolt steps. I don't have an option to change that. But now we have our starting off point for the test. So don't have an efficiency level yet. I think that comes after. So let's see, let's click the start button and see where that gets us. Might have to speed up the video again. I believe last time I did it without the Cinebench testing, so let's see what happens there. Ah, yeah, as I expected. Cinebench runs first, apparently. So let's put that on screen. 16 cores and 32 threads doing just beautifully. Okay, I didn't see the score on that, but it passed, so I guess that gives it some indication. Okay, we got efficiency numbers now already. So yeah, Core 1 and or CCX 1 and 2 are much more efficient than the other ones. So we can see it starting off with 4.2 gigahertz on both CCXs in the good CCD and 4.15 in the bad CCD with 1.225 volts. So let's see if it actually passes. It would be nice. I also think, yeah, it gives it like an efficiency rating. So mine is deemed a silver sample. So there might be gold samples out there who might get better overclocks or efficiency ratings. So if you're one of the lucky ones, congratulations. So that Cinebench run actually peaked us up to 79.9. Actually, the first time around, I think the max temperature it had set on was 80, which is, with my ambient temperature, not something that is very hard to hit, even with a liquid cooler. So I upped it to 85. Um, let's see. So I think if this passes with 4.2 and 4.15, which is already pretty good, that's almost a 4.2 gigahertz overclock on all cores with 1.225 volts. So stopped. Why? Oh, it finished. Okay. So what are they doing now? 50. Oh, it's just a different stress test. Okay. So if that passes, it might just run at that, which I wouldn't mind. That's better than what I was getting out of the box for sure. Because when I'm rendering video, usually the cores sit at about 4.1, but the core voltage is in the 1.3s. So that already should, like, thermally speaking, should be much, much better than the default Precision Boost 2.0 algorithm, what it was providing for me. So, which has been doing well. I mean, it's 16 cores, 32 threads. It does shred through renders pretty hard, even at stock settings. But if I can save myself some thermal headroom and actually have it running at higher frequencies, then why not? I'd be very happy with that result. Also, since I'm just talking while this thing is running, um, one Osmos in his guide also says, and this pretty much comes down to it, the better the VRM on your motherboard, the better the results will be that you will be seeing here. Because the power delivery and how clean it is a major factor of how low you can go on voltage while maintaining clock speeds, without errors, obviously. So yeah, keep that in mind. On B450 boards with like there are good ones. Don't get me wrong. Especially the MSI Arsenal line has some pretty amazing ones. Um, but if you're on something that has like a six phase design and generally already runs hot, um, yeah, don't expect any miracles out of this utility. But if you have good hardware, e.g., good VRMs on your motherboard, like for example, this is a hardcore overclocking board, Crosshair 7 or even the Crosshair 8. Or even the Crosshair 6 would be pretty hardcore. Uh, so it's got, I think this is a 10 phase design, 10 plus 2. So yeah, or is it 12 even? I keep forgetting. But I think you'll have best results with almost all B550 boards, because those are just insane. Like I think every board has at least 8 phases for Vcore, um, and a lot of them have much more, like 10, 12, some 14. So those are a good choice in my opinion if you want to get something out of this. Um, or very good X470 or B450 boards, like ones that actually have good Vcore ratings. Let me, for example, just show you this. I know it's running a stress test, so I'm actually taxing the system quite a bit, but there's lists like this where you can just see which vCore will be. If it runs cool, it usually means that it has no problem delivering fairly clean power. So yeah, these are like for current ratings and how much airflow you would technically need on this AM4 Vcore VRM rating. But I can put it in the description below. Basically, this will give you a good idea of the things that have a lot of green check marks are usually the ones that have better VRM solutions or designed. Yeah, so B450 or X470, there's good ones out there, but the majority of them are pretty crappy. So I wouldn't expect too much out of those. But X570, almost all of them are great. There's a few outliers here and there that, as good as MSI's B450 boards are, as not so great their or most of their X570 boards are, unfortunately. Gigabyte also has some less great ones, but overall they're okay. ASRock has okay boards, and ASUS has amazing X570 boards. So yeah. So I just got, okay, something failed. There we go. Okay. So some test didn't pass with these settings. We're already down to, oh, it went up actually to 4.225, and that wouldn't hold. Okay. CCX4 overclocking failure detected. So it's dropping CCX4 by 25 megahertz. So it went up on the Vcore by Vcore on the frequency for CCX1, 2, and 3 by another 25 at 1.225 volts, and it dropped. It now dropped 25 megahertz of CCX4, yeah, because it's the junk CCX with this 136 CPPC index. So yeah, let's see. I would be more than happy with these results. Like for all core, this is almost 4.2 all core basically. So yeah, I'm happy with that. I'm wondering how much of an effect it will actually have in games, because if I just leave it on regular Precision Boost 2.0, if I actually have a game thread, okay, which first of all this never happens for me because I play at 1440p, so or higher resolution. So very rare that any of my cores is pegged at above 4.4 gigahertz for any game. But we're gonna try and run Horizon Zero Dawn at 1080p and see if we can actually get one core to like hit its max, and then we're gonna see if this overclock has a negative effect on our FPS. If we are at lower resolution, I know at higher resolution it won't have any effect because I'm not even hitting. I don't think I've seen a core sitting at 4.2 gigahertz even when I'm playing Horizon Zero Dawn ever. So, but of course, this only I only prepared this one game for now. You see, the efficiency numbers are updating as the stress tests run. So we're seeing CCX4 got reduced in comparison to CCX3, and CCX1 and 2 got raised by, what is it, 0.004, because they actually passed on 4.225 gigahertz with the 1.225 volts. So yeah, that's basically, it's giving itself an efficiency rating for each CCX and then an overall efficiency rating for the CPU. So it's quite interesting. Red 25 failed. Okay. Well, I'll stop talking for now while this thing keeps running, and then we can have a. I'm gonna speed up the video, I guess, and then we can have a look at it in the end. So it looks like it finished, and this is what it came up with. So even though we were running successfully, from what I can tell, at 4.3 and 4.17 and 4.15, I guess for safety, it kind of drops the frequencies by another, what, 50 megahertz across the board for stability's sake. And we have a Cinebench result. How do I see that? Oh yeah, here we go. So this is the Cinebench score. I assume that, yeah. So the wattage difference is only like 1 watt per thread, I guess. That we're running higher than the default setting, but this is the default, just Precision Boost 2.0 per CCX frequency in Cinebench when it was running, and this is what we got now. So this is the time, or actually this is the voltage. It's running at lower voltage. It consumes more power though because it's running at higher clocks, but not massively much per thread. And basically we got overstock. We got almost, it's almost 500 points, like what, 460 points or something, 465. Um, that's pretty great. So essentially, for anyone who has done Zen 2 overclocking, it's an arduous process that usually takes a while because you're like overclocking each CCD or CCX individually, and then you see you're running stress tests and you're checking if it crashes, and then you try to evaluate which one is the worst, how low can I go on the worst, or how high can I go on the worst, and then you work your way up, and it takes a long time. I mean, this took like 40 minutes as well or something. But doing this manually takes much, much, much longer normally. So I think the reason why it even stopped here, because I think this passed actually, but because of our CCX Delta was set to 150 megahertz, and CCX4 earlier failed at 175, I believe. Yeah, here, Fred 25, which I believe would have to be somewhere here. Yeah, the first thread of this CCX, I believe, um, failed at that voltage, at that frequency. So that was dropped to 4.15 gigahertz, and then it just upped all the other CCXs, or actually the primary CCX or CCD, um, to the delta of 150 megahertz. So you can see these are running at exactly 150 megahertz more, and that's, even though it passed, it stopped. And then it looks like the whole thing just drops 50 megahertz across the board for all CCXs for stability's sake. Because, running a test for 5 minutes is one thing, but running it 24/7, I think this is pretty safe, a pretty safe way to do it, not like pushing it too hard to the limit. Because this might be somewhat stable in a 5-minute run, but it might throw the occasional error here and there. So 50 megahertz lower is very likely going to be stable. So yeah, but if you're doing manual overclocking, you you can achieve the same goal, but it is gonna take you much longer than this. I think I will, for now, create and apply this profile, See, it automatically says auto load profile on operating system start. I think that's just a setting in Ryzen Master basically. So let's see. We actually got our Cinebench score, so I'm not gonna like look at that, but I will have to find. So I'm not sure what resolution this will be in because it doesn't have a resolution setting when it's in Windows, but since I'm running on 4040p, this seems pretty indicative of somewhat around 1080p. Graphic settings, sure, why not ultimate quality? I'm running a 3080 on this system, so we shouldn't run into a GPU bottleneck there. Just to show as well. So what I'm interested in is how much GPU utilization. So we're definitely not hitting a GPU utilization peak, even though actually it might be. And the highest any of my threads runs at is at 80%, 4 gigahertz. Don't really see anything reaching 4.2 or any higher. Yeah, that seems to be in line with this. So for me, for gaming, this is gonna be like even on 1440p, this would be even lower, the CPU utilization, because the graphics card would actually have to work harder. We would be more GPU bound, or probably completely GPU bound, and yeah, this would have no effect on me. So for rendering, this is gonna be faster, and for gaming, it's probably not gonna have any effect whatsoever. So we're gonna validate that. We're gonna let this benchmark run real quick or finish real quick. And then we're gonna see how it runs or what the FPS is or overall value is if we run the same benchmark without the whole optimization of the CPU frequencies for all core overclocking through Clocktuner for Ryzen. So let's see how this goes. And this I forgot this benchmark is so long. So yeah, it's 1080p, 110 FPS average, with ultimate quality. Oh, that's a nice score. Wow, I couldn't get that in 100 years if I tried to. Sweet. Perfect. So let's see. How do I reset profile? You're running at stock now. Hope I can open Ryzen Master. Wow. Okay. Wow. Okay. That's still okay. Nope, that didn't reset jack. So back to stock. 4.7 is bull crap, and the voltage much higher now. So this is definitely stock settings. Regular power limit, blah, PPT, etc. Okay, so let's go back here. Discard the changes. Yes, run the benchmark again, and see what happens. I kind of forgot to remember. What was it? 110 FPS average or something? 20,000 was the score. That was easy to remember. So I'm gonna speed up the video again. And let's see if we're getting a lot more frames and any cores that actually do jump to a higher frequency than 4.2 even. But as we can already see, even with the default settings, the cores are sitting at most at like 4 gigahertz, just above 4 probably. So this is a well-optimized game, so it kind of uses a lot of cores, like you say, to a certain degree. But usually there's one game thread that is kind of limiting. But let's let this benchmark run and see if we're getting worse numbers in games with this optimization for better overall frequency rather than allowing a single core to hit 4.5 gigahertz. In a game like this. I promise you, in games like CS:GO or whatever, yes, it would be a limiting factor, in my opinion, because if you're running 1080p and then definitely one thread on your CPU is pegged at 100%, because it's just trying. It's the game thread that's trying to drive all the frames. So if you're CPU limited on the game, then I don't think this is gonna be advantageous. But to be honest, if you're CPU limited on any of these games, well, then you're probably running in excess of 240 FPS, because it's probably only esports titles at very low uh, resolution that really uh, get your board to like 100% to be pegged at 100%. Anyway, let's speed it up again and see the result. So the test is over. Let's see. Oh, that's terrible. So you see, this is a well-optimized game, and despite the fact that I genuinely thought, okay, we're probably gonna see somewhat similar results in games, because Precision Boost 2.0 is just gonna, use a couple of cores for whatever it needs to provide higher frame rates, while the rest will be like doing their like thing. But you can see, with the better efficiency that we have, running the cores at higher frequency with lower voltage, or high frequency with lower voltage, um, I guess the thermal headroom and everything just makes a huge difference, because we're 20 FPS lower, I believe, as 4,000, almost 4,000, or let's say 3,000, what is it, 642 or whatever, lower on the score. That is massive, massive. Again, well-optimized game, does utilize the CPU quite a bit, does use a lot of RAM. Um, and but we were not GPU bound, so this is pretty much on the CPU, in my opinion. You see, CPU FPS is much lower than GPU FPS, so yeah. Actually, yeah, yeah. It's honestly quite surprising result for me. Um, Again, games like esports style titles, yeah, you might want to just have Precision Boost 2.0 turned on and let one core fly, and go crazy and hit 4.5 gigahertz or 4.6 gigahertz or whatever, just to get those extra frames if they really matter to you. But in my opinion, for someone like me, okay, I'm gonna do my own overclocking or whatever, most likely, but for someone who has a 16-core CPU, isn't very apt at overclocking or whatever, this is an extremely compelling way to get a lot more performance, better thermals, and just with minimal effort, in my opinion. This took 40 minutes, I think, to run the stress tests and so forth. It might take an hour if you put a larger delta or whatever, so it can actually go to a higher distance between lowest and highest core. But even so, that is incredible in comparison to what you would have to do to get to this result by yourself. So, and you get a lot more value, in my opinion, out of this CPU, because if you're rendering video with just the profile that it created for me with the 4.25 gigahertz, this is higher than it runs out of the box all core. Because I usually sit at 4.1 all core with Precision Boost 2.0 when I render a video. And that's with like 1.3 something volt used as well, shoved through the CPU. So that's pretty amazing. Yeah. I think I'll end the video here. I think people can extrapolate from the results what they want. I think this kind of speaks for itself. If you have a motherboard that has a good VRM solution, you can find information about this online. I said I'll post the the one for the AM4 platform, in the link below. B550, you essentially don't have to worry. All of those are freaking overbuilt as heck. So if you have a good VRM solution on your motherboard, and you're running a 3000 series CPU that is supported by the utility, which I'll also just quickly bring up here, which I think is here. Again, no Renoir CPUs, so no APUs are supported, unfortunately. And yeah, mine is also only on the yellow support list, but you see it worked pretty well. And unfortunately, the 3990X, if you can afford that, it's also not supported. But for majority of users, I think you'll find yourself somewhere in this group. This is definitely worth it. If you're not apt at overclocking, per CCX overclocking and CCD overclocking by yourself, or you just don't want to invest the time because it takes a lot of time, consider this. This is amazing. Again, Yuri, thank you so much for creating this utility. I'm looking forward to the official release, the non-beta release. I hope you get a lot more data maybe from people who are running this utility for like CPUs like mine that doesn't have any additions, tweaks, whatever that means, by the way. And yeah, so you can actually optimize this. And I mean, Ryzen 5000 series is about to launch, so you might have your work cut out for yourself in regards to that as well. I'm not sure if you'll have a lot of time to invest in this project anymore, but I'm really happy I got to use it. I got to try it out, and yeah, this is pretty. As you see, 4.04 is what it ran at default in Cinebench R20. Yeah, this is incredible. Good job, and thank you guys for watching this video. If you enjoy this kind of content, please leave a comment, let me know, or leave a like, and I'll be sure to make more of these type of videos. And yeah, like, share, and subscribe if you can. And I'll see you again in the next video. This was Julian with Mainstream PC. Cheers.